Hi everyone! Welcome again to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. And this channel will help you understand about the basic concepts of mathematics. And it will help you realize that math is not a difficult subject, but it is a fun and interesting. Again, this channel is intended to those who are doing the online classes and also those who are doing their modules or answering their modules. This will help you understand your lessons in mathematics. Please do not forget to share this video discussion to your friends, especially those who are struggling, for them to improve their performance in mathematics. That is a very nice advocacy in life to help other people to learn mathematics. So, are you ready for our next discussion? Yes, I know you are ready. So, our topic for today will be a continuation with the patterns and nature of mathematics. Yeah, patterns in nature rather. And of course, regularities in nature. That is our main focus in today's video discussion. So please do not forget to subscribe my channel, share this one to your friends, and I wish everybody a very nice Christmas. So Merry Christmas in advance to all of you. So now let's start our discussion. So as I have said, we will be talking about some patterns and regularities in mathematics in the modern world. We will start with or in related to or in relationship with the one that we talked about last time about patterns in nature and regularities rather in nature is about the Fibonacci sequence. So Fibonacci sequence is a pattern. Yes, it is a pattern in nature and it shows regularity also. So let's try to define what is Fibonacci sequence. Fibonacci sequence is a mathematical sequence which occurs throughout nature as well as in music, art, and popular culture. So the Fibonacci sequence are the following numbers in the integer sequence. As you can see, there are Fibonacci sequence that starts in 0, and others will use 1 as their starting point, okay, or starting term. So in this example, we start our integer or our sequence in 0. So the Fibonacci sequence are the following numbers in the integer sequence. We have the 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. So the definition for Fibonacci sequence is as follows. If f sub n denoted for Fibonacci sequence, f sub n is equal to f sub n minus 1 plus f n or sub n minus 2, where f sub 0 is equal to 0 and f sub 1 is equal to 1. So let's try to describe the pattern. This is what the pattern says. So 0, this one, 0, if our starting point is 0 or starting term, then our next term will be 1. That's why we have it f sub 0 is 0 and f sub 1 is 1. So if 0 is our starting point, we will just add them 0 plus 1. So 0 plus 1 becomes the next term. And then 1 plus 1 becomes the next term, 2. 1 plus 3 becomes the next term, 3. Okay? 2 plus 3 will be the next term, 5. 3 plus 5 will be the next term, 8, so on and so forth. So that is the meaning of the sequence based on its notation or formula as f sub n is equal to f sub n minus 1 plus f sub n minus 2, where f sub 0 is 0 and f sub 1 is equal to 1. So you can also have to start, or you can also start your Fibonacci sequence as 1, then 1, 2, then 3, so on and so forth. It's up to you. Which first term do you want to start? Do you like to start it in 0? Then you can. You want to start it in 1? Yes, you may. So it's up to you. So this is the notation of Fibonacci sequence, and this is how we define it in here or in this slide. So our next, okay, sorry. So, what is the history of the Fibonacci sequence? It's very important for us to know the history. When and where did Fibonacci discover this kind of sequence? Because when you know the history of a certain concept in mathematics, it will be easier for you to understand and appreciate its symbols and especially its lessons. So, the exact origination of the Fibonacci sequence is unknown because during that time there is no calendar yet, perhaps that's why its origination is unknown. It is believed that contributions to the theory began in 200 BC. So this is just only a, yes, just a belief, no proof to this rather, 200 BC, by Indian mathematicians whose studies were based on Sanskrit prosody. So the sequence was introduced to Western European mathematics in 1202 or 1202 or 1202 by Leonardo of Pisa, aka Fibonacci. So Leonardo of Pisa and Fibonacci, they are just the same person. Okay? So Leonardo of Pisa, aka Fibonacci, was the one rather who introduced to Western European mathematics about the concept of Fibonacci sequence. So let's bring it on. His study of the sequence began with the breeding patterns of rabbits. So Fibonacci or Leonardo of Pisa used the patterns, or he used rabbits or the breeding patterns of rabbits to discover and study the sequence or the pattern in Fibonacci sequence, in which he found rabbit generations duplicated in accordance with the Fibonacci numbers. So this is the history of the Fibonacci sequence. So what is Fibonacci sequence? Again, what is Fibonacci sequence? Fibonacci sequence is a series of numbers that follow a unique integer sequence. So as you can see, it may start in 0 or 1. So if you start it in 0, then you have it 0, 1, 1, 2, 3, so on and so forth. And if you want to start it in 1, then you have it 1, 1, 2, 3, so on and so forth. So these numbers generate mathematical patterns that can be found in all aspects of life. The one that we mentioned in the previous video discussion about nature of mathematics and also the patterns and regularities of nature. So the patterns can be seen in everything from the human body to the physiology of plants and animals. So the Fibonacci sequence is derived from the Fibonacci numbers as I presented a while ago and also here. So the Fibonacci sequence is the series of numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, so on and so forth. The next number is found by adding up the two numbers before it. Okay? So 0 plus 1 is equal to 1. That's why it's the next term. Then 1 plus 1 is equal to 2. That is the next term. So the 2 is found by adding the two numbers before it, 1 plus 1. Similarly, the 3 is found by adding the two numbers before it, like 1 plus 2 is equal to 3. And the 5 is 2 plus 3, and so on. So this is the pattern for Fibonacci sequence. So more on Fibonacci sequence. As you can see, this is the pattern. So this is the first 2, 4, 6, 8, 10, 12, 14. First 14 Fibonacci sequence. So you have it 1 plus 1, 2, 2 plus 1, or 1 plus 2, 3, 2 plus 3 is 5, 3 plus 5 is 8, then 5 plus 8 is equal to 13, so on and so forth. So this is the concept and then the pattern itself. Now, Fibonacci sequence, as I mentioned and as we defined it a while ago, a series of numbers starting from 0 where every number is the sum of the two numbers preceding it. So example 0, 1, 1, so on and so forth. It is named, the word Fibonacci was named after Fibonacci, an Italian mathematician, again, Leonardo of Pisa. year 1000 or 1202. Okay, the year 1202, this is the year it was first introduced to the Western world in the book of Liber Abaci or Abasi. So mathematical formula for that, you can have it x sub n is equal to x sub n minus 1 plus x sub n minus 2. Or you can have it f sub n. You can replace f to your x. Fn minus 1 plus Fn minus 2. Okay, so 1.618, this one is the equivalent value of phi, or the golden ratio. We will be talking about the golden ratio after this. The ratio of any two consequent numbers of the sequence in Fibonacci. So the nature's code, because of it is observed in several natural phenomena. Since Fibonacci sequence can be seen and very obvious, yeah, tangible to our two naked eyes in our nature, so we have a nature's code for that. Again, the reason, because it is observed in several natural phenomena. So now let's proceed to the next slide. So we talked about golden ratio a while ago in Fibonacci sequence. So the golden ratio is about 1.618. It's like, or it is represented by the Greek letter pi rather. The golden ratio is sometimes called the divine proportion. Why? Because of its frequency in the natural world. The number of petals on a flower is an example of a golden ratio. For instance, will often be a Fibonacci number. So, examples, seed heads is subject to Fibonaccian or Nachian rather processes. So as you can see that, okay, so there is a pattern. Yes, golden ratio, divine, it has divine proportion in a natural way. So it can be applied there, the concept of Fibonacci number based on its structure or pattern. Another golden ratio examples are the pine cones are arranged in a spiral pattern like that. So it's like Fibonacci sequence. Okay, it's part of a golden ratio. Another example for a golden ratio are tree branches. So the Fibonacci sequence can also be seen in the way tree branches form or split. Look at. So see the branches, you started it by 1, 2, 3, 5, 8, 13, so on and so forth. It's like Fibonacci sequence. The three branches shows the Fibonacci sequence. Okay? Form or split in it. So another thing also are the shells. It is called the logarithmic spiral, and it abounds rather in nature, as you can see in the illustration. These are examples of golden ratio in Fibonacci sequence. So another example are shells. Another example of golden ratio under Fibonacci sequence are spiral galaxies and hurricanes. So see, there is really a pattern in it. So now we will talk about the importance of mathematics in life in our next video discussion. So I hope you have learned something in this video discussion, and I hope you continue to subscribe my channel and watch all the video discussions, and you are not just wasting your time while watching my video discussion, because you are learning in this video discussion. So thank you for listening. Always remember that the essence of mathematics is not to make simple things complicated, but to make simple things, what I mean is to make complicated things simple. So math is fun. Thank you for listening. Have a good day. Please subscribe my channel. And of course, please put your comment, in your learnings in this video discussion in the or below the video discussion in the comment section. Thank you and have a great day.